in this problem, we have an electron moving north in the Earth's magnetic field at some velocity that we're given here. And we want to find what the force of the Earth's magnetic field is on the electron. So to start this problem, we can recall the equation for force on a point charge due to a magnetic field, which is just F equals Q, where Q is the charge of the point charge, V, the velocity of our point charge, cross product with the direction of the magnetic field, B, or cross product with the magnetic field, B. We are told the magnitude of all these, so to figure out how to evaluate the cross product, we'll have to figure out the relative directions of these two. We're told that the electron is traveling north, and so we'll assume that it's traveling north roughly vertical to the horizontal surface of the Earth, at least locally, since the Earth isn't flat. And we'll call that like that. So this is the velocity of our electron V. And we're told that the magnetic field of the Earth is 45 degrees below the horizontal. So we can say that the magnetic field of the Earth is like that. That's B, and this is 45 degrees. For evaluating the magnitude of a vector cross product, we know this to be equal to the magnitude of the two vectors times the sine of the angle in between them. And since our angle is 45, sine of 45 is root 2 over 2. Now all that's left, since we have the value of this cross product and we're told all of our other variables, we can just plug everything in to get the magnitude of the force. So F equals Q, which is 1.6 times 10 to the negative 19th coulombs, times the magnitude of our velocity, which is 4 times 10 to the 5th meters per second, times the strength of our magnetic field, which is 5 times 10 to the minus 5th Teslas, times sine of 45, which is just root 2 over 2. And I'll do a bit of math here with these powers of 10. Since this is negative 5 and this is 5, these cancel out with each other. So I'll just take 1.6 times 4 times 5 times root 2 over 2 times 10 to the minus 19 to make it somewhat easier to plug that into my calculator, which is going to be 1.6 times 4 times 5 times square root 2 over 2 is 32. So that's 32 times 10 to the power of minus 19 newtons. And then we can shift this over a bit so that this is written in scientific notation. So that should give us 3.2 times 10 to the minus 18 newtons. And that's our final answer. Hopefully this video was helpful.